We're going to be using these two figures for numbers 9, 10, and 11. These are similar figures. I know that because we've got a similarity statement there that shows that they are the same. And so we're going to do a couple things. First of all, number 9 tells us we're going to find the scale factor to take us from the small figure to the large, or vice versa. And then we're going to find the values of some missing variables here. We've got x, y, and z. And then the last one we're going to kind of talk about, but not actually fully complete it, find the perimeter of each polygon. Okay, so the first thing, finding the scale factor, we have to recognize the scale factor comes from looking at corresponding parts between these two. Whatever that ratio is, that's your scale factor. Okay, so I've got ratios set up here where the numerators are all filled in, but I'm missing the denominators. Okay, so the numerators are just the sides of this small triangle, or small figure, excuse me. So HG, here's GF, FE, and EH. That's just what I've got laid out here. Now we've got to match them up with their corresponding parts from the larger figure. So let's start with this one over here. HG, it's the smallest segment. It should match up with ML if the diagrams are correct, but we don't want to always assume that. So let's go back to our similarity statement. H and G are the last two letters of this figure. They must match up with the last two letters of that figure, which is LM. Okay, we thought that's what it was going to be, but we should always be double checking that for sure. We'll do the same thing with GF, which is this segment on the side. G and F are the two middle letters here, and so it must match up with KL. FE are the first two letters, that matches up with JK. And EH matches up with JM. Okay, so these are the scale factors, the ratios between the two figures. The only problem is I don't actually have any values with them. So I'm going to just rewrite that same thing. 4 different ratios. And we know these ratios have to be equal to one another, so we'll put a little equal sign in between. And let's just fill in what we know. Okay, HG is 3. LM, we don't really have anything there, not even a variable, so I can't put anything down here. Let's fill in GF, which is 11. KL that goes with it is X, that's a variable. FE is 8. And JK is 20. And then the last one, EH over JM, EH is Y. And JM is 30. Okay, so these 4 ratios are all equal to one another. They're also all the scale factors. The problem is I don't really know what this means. I don't know what that means because it's got a variable. I don't know what that means because it's the variable. This is really the only one that tells me what my scale factor is. My scale factor is 8/20. Now I'd want to simplify that and say the scale factor is, let's divide 4 out of both of those, 2/5. Okay. Scale factor is 2/5. What that really means is for every 2 units here, I've got 5 units here. Or you could say, if I want to go from this larger figure, I'd have to multiply it by 2/5 to get down to this one. Okay, so we've accomplished number 9. We found the scale factor of 2/5. Find the values of x, y, and z. All right, we'll list those over here when we find them. The easiest one to do is probably z. Z is listed as z degrees. Now, since that is coming off of angle E, we know angle E matches up with angle J. Here's E, here's J. Those two things must be the same, so Z has to be 65. I'll list that over here. The other two are a little trickier, and you can see this is where we had X, this is where we had Y. This is the only ratio where we knew the actual value. We're going to use these 3 things here to solve for X and Y. So first I'm going to use just this ratio and this ratio. 11 over X is the same as 8/20. And again, if it were up to me, I would simplify that and call it 2/5. Okay, 11x equals 2/5. Now I've got a ratio and I can just cross multiply. There's 2x. It should be equal to 55. When we divide both sides by 2, x has to be 27.5. List that up here, 27.5. we're going to do the exact same thing to solve for y, except for this is the ratio we're going to use. The one with the y variable in it, and then the ratio where we actually have all the values. So again, just to rewrite it, 8 over 20th equals y over 30. Let's call this 2/5 to make it easier on ourselves. And I cross multiply. 2 times 30 is 60. That should be equal to 5y. When I divide both sides by 5, y equals 12. Okay, so I've got my x, my y, and my z variables that I can plug in there as well. We've done 9, we've done 10. The last one, number 11, just says find the perimeter of each polygon. Essentially, you would be doing the same thing. We've got all of these values that make up the perimeter of this smaller figure. So 3, 11, 8, and we found y to be 12. We could try to find, we already found x, we're missing this length here, so what we could do, we could take its corresponding side, which is 3, and multiply it by 5/2 all up. We could take this entire perimeter, 3 plus 11 plus 8 plus 12, that'd be 20, that'd be 34. We could multiply that entire perimeter of 34 times 5/2, that would get us this entire perimeter. So a couple different ways to do it at that point.